So we'll start with the key paper of the chemistry examination. The first question in this states that the wave function of the 2s is given by so and so. At r is equals to r naught, the radial node is formed. The r naught in terms of a naught is asked. So as we know, the probability of finding an electron which is denoted by psi is zero whenever it is at radial node. So psi value is zero at a radial node. So if psi value is zero, so whatever these terms are present, if this term is zero, whatever these terms are present, they will be going on that side and will become zero. This term is also in multiplication. This will also become zero. If these two terms become zero, what will be remaining? 2 minus r by a naught is equals to 0. I can edit as 2 is equals to r by a naught and r is equals to 2 a naught. So the answer would be second option. Next, we'll go to the next question. That is this one. In this question, this is like a direct question from NCERT. The Planck's quantum theory explains us black body radiation, photoelectric effect, spectrum. It will not explain the internal energy rise due to temperature. This is not explained by the quantum nature of the atom, which was explained by Planck's quantum theory. Okay, so the option would be fourth option. Next, bracket series, as we know, if it is first orbit, if anything comes from infinity to first orbit, it is Lyman series. And infinity to second orbit, it is Balmer series. Infinity to third orbit, it is Bastian series. Infinity to fourth orbit, it is bracket series. I think this question key paper was wrong. So whoever has kept third option, that would be correct. Add plus 4 marks if you have added, if you have kept third option. Okay. The third option is correct answer from this. N5 to N4 would be bracket series. Then total spin resulting from a 3D7 configuration. 3D7 would look something like this. 1, 2, 3, 4. 1 and the second. First, I'll add all those 2, 3, 4, and 5, and 6 and 7. When you multiply all the spins of this red color electrons, it would be plus half into 5 plus minus half into 2. So this and this goes to 2.5, 2.5, 2.5 minus 1, which is 1.5. 1.5 is nothing but 3 by 2. That is first option is the answer. Next, in this question also, the options are, I think the options that were given as wrong. So you can add plus 4 marks for this question also. So in this is 3s. This is 2d. 2d is not possible. This is 4f, which is possible. 4f is possible, and minus 2 quantum number, magnetic quantum number is also possible because if 3 is the what do you call azimuthal quantum number, it will start from minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So then we have got this 1s for this magnetic quantum number must be 0. So this is also not possible. So second is not possible, fourth is not possible. This is 3d, but the thing is, it should not have magnetic quantum number this. So 2, 4, and 5. These are not possible. Next, a 0.66 kg of ball is moving with the speed of the associated wavelength. For any particles, the wavelength will be given by de Broglie's wavelength. Lambda is equals to h by mv. Lambda value is, that is what we have to find out. Speed is 100 meters, 6.6 into 10 power minus 34 upon mass is 0.66 kg into 100. So 0.66 can be written as 66 by 100. 66 by 100 means I can cancel out this 100 with this 100. So I'll be left out with 1.1 into 10 power minus 34. This can be also be written as 1 into 10 power minus 35. So the option would be second option. 1 into 10 power minus 35 meters. The option would be second option. Next, let us move to uncertainty in position. As we know, the Heisenberg uncertainty principle states that delta x into delta p must be greater than or equal to h by 4 pi. If delta x value of an electron, the uncertainty in position of electron, and uncertainty position of helium, if these both are same, and they are also giving h by 4 pi, that means the momentums must also be same, because if these two are same, if 2 into 3 is equals to 6, then if the other one is also having 2, this one also must be 3 to get the same value. So if uncertainty in positions are same, that means uncertainty in momentums also must be same, because their product must be greater than or equal to h by 4 pi. So what I can say here, I can say if uncertainty in momentum is 32 into 10 power 5 for electron, uncertainty momentum for helium will also be 32 into 10 power 5. Next, the wavelength of the light emitted 5 to 1. So as we know this, we have to use Rydberg's equation here. Rydberg's equation states that 1 by lambda is equals to R into 1 by N1 square minus 1 by N2 square. Into Z square, it doesn't matter because it is hydrogen atom. So 1 by lambda is equals to R into 1 by, it is coming 1 square minus 1 by pi square. So 1 by 1 square R into, if I take LCM, that would be 25. And 25 minus 1 is 24. If this is 1 by lambda. And then lambda is equals to 25 by 24 into R. As I have taught you, 1 by R, please remember it as 911 angstroms. So 25 by 24, it is almost equal. So this would give me 911 angstroms nearly. 911 angstroms is nothing but 911 into 10 power minus 10 meters, which can be written as 9.11 into 10 power minus 8 meters. So the answer would be third option. Third option would be the answer for this question. Next, let us move to an electromagnetic radiation of 300 nanometers falls on a surface of a sodium. Electrons are emitted with a kinetic energy so and so. Here you should understand the mole concept here. 1 mole is equals to 6 into 10 power 23 molecules. Okay. So this concept you must know here. So 1 mole is equals to 6 into 10 power 23 molecules. When electromagnetic radiation of wavelength, so 300 nanometers is falling on the sodium. So per mole 1.6 into 10, 1.68 into 10 power 5 joules of energy of electrons is emitted. So E is equals to work function plus kinetic energy of the electron. So for 1 mole of electrons, the energy is 1.68 into 10 power 5. Now, what is for 1 electron? How much energy will be required? So that would be 1 by 6 into 10 power 23 into 1.68 into 10 power 5. This would give us so let us keep it as it is. So 1.6 by 6 into 10 power minus 18. Let us keep it like this. Now let us come to work function. This is 300 nanometers, so I can write it as hc by lambda. So 2 into hc value also you must remember it is 2 into 10 power minus 25. It will be easier for calculations in this case. 2 into 10 power 5 upon wavelength is 300 into 10 power minus 9, which is equals to work function is how much? That is what he is asking. Plus kinetic energy is 1.6 by 6 into 10 power minus 18. So if you do the calculation, this calculation is if you do it, that would give you work function is equals to, if I 2 ones to 150s. Okay. So this would give me 1 by 150 into 10 power minus 15, 16 minus 1.6 will approximate it to 1.8, 0.3 minus 0.3 into 10 power minus 18. So that would give me 1 by 1.5 into 10 power minus 18 minus 0.3 into 10 power minus 18. Sorry, this would be 1 by if into 10 power 9. So this would be correct. Then do the calculation. This, whatever answer you are going to get, that is your work function. Okay. So once work function comes, then what we have to do, work function, as soon as work function comes, work function is equals to h nu naught. So then you have to find out the threshold. See, nu naught is nothing but hc by lambda naught. You have to find out the threshold wavelength. Okay. So please do the calculation for this question. Next, we'll move to next question, that is the graph between psi square and radial distance is shown below. This represents, this is my radial node. The infinity and the nucleus must not be considered in radial nodes. So how many radial nodes are there? One radial node. Radial node formula is n minus L minus 1. So n minus L minus 1 is my radial node formula. And the graph will be starting from S orbitals graph will start from maximum at the nucleus. F graphs will start from origin for these things. So n minus L minus 1 for this, 3 minus 0 minus 1, which is 2. 2 minus 0 minus 1, which is 1. 2 minus 1 minus 1, this is 0. 1 minus 0 minus 1, this is also 0. So the answer is second option. Let us move to next question, that is how many nodal planes are present in 4D z square? This is not there in your portion because 4D z square will look something like this. It will have conical nodes. Okay. This doesn't have a planar nodes. It will have a conical nodes, which is not there in your syllabus. So whoever has put for 0, they can also take marks, but the and whoever has put the answer as 2, which is L value is equals to 2 for nodal planes, they can also take marks for this question. So next, how many set of quantum numbers are possible? So set of quantum numbers that are possible, 2D, this is not possible. 3D, yes, this is possible. 3D, yes, it is possible. 2P, yes, it is possible. So 3 values are possible. Next, we'll move to another question. Set of quantum numbers that represent the degenerate orbitals. So degenerate orbitals, the energy of the orbitals we can find out by n plus L rule. So if I find out by n plus L rule, 3 plus 2, that is 5. And here also it is 5. This is 3. This is 4. This is not degenerate. This is 6. This is 5. This is also not degenerate. So only A is the answer for this question. Next, there can be 5 electrons for which MS is, yes. So the atomic number 9 is 1s2, 2s2, 2p5. So 1s2 if I take, it will be 2 electrons, 2s2 if I take, it will be 2 electrons, 2p5 if I take, that would be 1, 2, 3, 4 and 5 electrons. So this can be like pz also can be present here, px also can be present here, py also can be present here. It's not mandatory that the electrons will enter into px, then py, then pz. It's not like the electron is entering into pz, the last electron is entering into pz. It is nothing like that. They are all degenerate orbitals. They are same energy orbitals. Electron can enter into any one of them randomly. So there are 5 electrons with ms half and ms minus half. That is correct. Yes, because 1 electron half, 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 and half. 5 electrons are with plus half. 1, 2, 3, 4. 4 electrons with minus half. This is correct. There is only 1 electron in pz orbital. This is ambiguous. We don't know whether there is 1 electron in pz or in any other orbital. So let us see the options, then we'll mark this. Then the last electron goes into n is equals to 2, L is equals to 1. Yes, this is also correct. The sum of angular nodes of all the atomic orbitals is 1. So for this atomic orbital, the sum of angular nodes is denoted by the azimuthal quantum number. This is 0. For this also it is 0. For this, there are 3 orbitals. For this it is 1. For this it is 1. For this it is 1. So 1 plus 1 plus 1 is 3. So this is wrong. So for me, A, B, C, D, A, B, C are correct. If such option is there, mark it. If such option is not there, then you have to go for the options that are given here. In this, I can see A and C are correct. So the option is A and C are correct because B option has not been mentioned with the C. A, B, C has not been mentioned. So I'll be going with the most appropriate option given, that is A and C. Next, we'll move to the extra stability of half-filled subshell is due to Yes. Symmetrical substrate distribution of electrons. Yes. Smaller Coulombic repulsion energy. Yes. Presence of electrons with same spin in degenerate orbitals. These are all same energy orbitals. So whatever d orbitals that we are drawing, they are same energy orbitals, and he's saying non-degenerate orbitals. This option is wrong. Larger exchange energy, yes. Relatively smaller shielding by one another is also yes. So 1, 2, 3, 4. A, B, D, E are correct. That C is wrong. Next, let us move to this question, chromium, ground state. So chromium, as I have taught you, it will have an abnormal configuration. The configuration, if you write, you will be writing something like this: 3s2, 3p6, 4s2, 3d4. This is what you write normally. But the thing is, chromium will have an abnormal configuration. It will be something like 4s1 and 3d5 because the half-filled d subshell is stable. So now, how many electrons with azimuthal quantum number L is equals to 1 and L is equals to 2 are present? L is equals to 1 are p subshells. Here 6 electrons, here 6 electrons, and here we have got 5 electrons. 6 plus 6 is 12. L is equals to 1, we have 12, and L is equals to 2, we have 5. The option is B option. Okay, the option is B. Then, which are the following about an electron occupying the 1s orbital in a hydrogen atom is incorrect. Incorrect. So incorrect is the probability of density of finding electron is maximum at the nucleus. This is correct for S. The probability of finding the electron is maximum at nucleus. The total energy of the electron is maximum when it is distance of A naught. No, no. This is minimum. This is minimum. Okay. So distance, see, total energy, we find it as minus 13.6 into z square by n square. So as we move, like the shells are increasing, the total energy will be decreasing because you can see n value is down. So total energy would be decreasing. That is, it would be minimum whenever it is present at larger distances. The electron can be found at a distance to enough of the nucleus. Yes, electron can be found anywhere. One is orbital is spherically symmetrical. This is also correct. So incorrect is this one. This one is incorrect. So option is B. Next, for electron 2s and 2p orbitals, the orbital angular momentum values respectively are under root of L into L plus 1 into h by 2 pi is the formula given by Sommerfeld to find the orbital angular momentum values. This is orbital angular momentum values where Bohr has given electron angular momentum, which is mvr is equals to nh by 2 pi. There are two different formulae for this. So, or whenever the orbital angular momentum is given, that is given by Sommerfeld under root of L into L plus 1 by into h by 2 pi. So now for a 2s, L value is 0. So 0 into anything would be 0. Okay. So this is 0. For P, it would be L value is 1. 1 into 1 plus 1 into h by 2 pi. 1 into 1 plus 1 is how much? It would be 1 plus 1 is 2. 2 into 1. So 2 into under root of 2 into h by 2 pi. So option would be this. 0 and 2, root 2 into h by 2 pi. Then, which are the following postulate of Bohr's is not in agreement? Not in agreement. Please, you should be very, very careful with these words. Not in agreement with quantum mechanical model. The electron stationary states move in circular around the nucleus. There is not in agreement. Yes, this one. This one is the quantum mechanical model says the electron can be present anywhere, whereas Bohr's model states the electron is present in the orbit. So this is the option for this question, and remaining all they are in agreement only. Then this question, I think all of them have done it wrong. So total energy of the electron. So we are plotting the energy of the electron versus the z. So total energy of the electron is equals to minus 13.6 into z square by n square. So total energy is directly proportional to minus z square. It is not plus z square. It is proportional to minus z square. There is a negative value here. Whenever there is minus z square, the parabola will become inverted. So if it is inverted parabola, the answer would be second option. Second option would be the answer for this question. Next, threshold frequency, kinetic energy. So we know this photoelectric equation again. So energy of a photon is equals to work function plus kinetic energy. Kinetic energy is equals to energy of the photon plus work function. Energy of the photon can be given as h nu. Sorry, energy of photon minus work function minus h nu naught. H, if I take common, nu minus nu naught. So nu value is 1. Yeah. So 10 power 15 minus 6 into 10 power 14. So H value is 6 into 10 power minus 34. If I take 10 power 14 common out of this, so I'll be left out with 10 minus 6, which is 4. So 6.6 into 10 power minus 34 into 10 power 14 into 4. This would give me 6 fours 24, 4, 2, 6 fours 24, 25, 26, 264 into 10 power 26.4 into 10 power minus 4 minus 4 is 0, 3 minus 1 is 20. So that would be 2.64 into 10 power minus 19. That is the answer. The option is second option. 2.64 into 10 power minus 19 is the answer. That is second option for this question. Next. Which of the following is again not correct? You have to be very careful with this. Not correct with respect to hydrogen atom. So for hydrogen atom, we are bothered only about the principal quantum number. We are not bothered about the azimuthal quantum number. So principal quantum number, if I take principal quantum number is, so 1s is less than 2, then less 3, then this is in agreement. This is correct. 1s, 2s is equals to 2p. 3s is equals to 3p. This is also correct. 1s is less than 2s, 2s is less than 2p. This is wrong for hydrogen because hydrogen depends only on the principal quantum number. 2s must be equal to 2p. So this is the wrong one. And 1s, 2s, and 4s, this is also wrong. So C and D are wrong in this case. The option would be fourth option. Next, in a multi-electron atom, which are the following orbitals described by 3 quantum numbers have same energy? If you want to have same energy, n plus L value must be same. First one, n plus L value is 1, 2 plus 0 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 3 plus 2 is 5. So D and E are the degenerate orbitals which will have same energy in the absence of electrical and magnetic field. So the option would be D and E. Next, for hydrogen atom, the lowest energy for hydrogen atom. Hydrogen, we should see only the principal quantum number. So all these three will have same energy, that is lowest in the comparison when we compare with the others. So B, C, D is the answer for this question. Next, heat treatment of the muscular pain. This is, as we have done this in class also, spectral line 1 by lambda is equals to R into 1 by n1 square minus 1 by n2 square. So 1 by lambda is how much? Is given 1 by 900 is equals to R value into 1 by so definitely it is heat wave. So it should be Paschen series, either this or this. So let us check with this whether we are getting the same. So 1 by 3 square minus 1 by infinity square. I think this is the answer. So R into 1 by 9, 1 by 900. R value is equals to 9 by 900. Yes, this is the answer. So that would be Paschen series infinite to 3. This only can give us, let us check that. So 1 by lambda is equals to R into 1 by, what do you call, infinite 3 square minus 1 by infinite square. So R value we don't know, R into 1 by 9. So 1 by lambda. So lambda is equals to 9 by R. So 9 by R. So 9 by R in the sense 9 by R. So we are getting, let us check for this one also. Paschen series 5 to 3. 1 by lambda is equals to R into 1 by 25. Sorry, 1 by 9 minus 1 by 25. So that would be R into 25 minus 9 upon 25 nines to 25. So 25 minus 10 is 15, 16 by 225 into R. Lambda is equals to 25 by 16R. This is not going to give us 900. This is going to give us 900 nanometers. So because this is 911, yeah, 9 by 911, which is nearly 1 by 100. 1 by 100 is 1 divided by 100. Yes, this is going to give us that 900 nanometer wavelength. So the option would be D. D option is the answer for this question. That's all. So with this, we have finished this exam.